Okay, hi everyone. So this is FBD4. This one is slightly complicated, but let's go through it. Okay, so again, determine your object of interest. There's one object here, there's another object here, but I think the object of interest is this thing actually. Okay, this bar over here is what we are interested in. Again, represent it with a line. Okay, so first thing is, does the bar has mass or not? If yes, then since it's a uniform rigid body, we assume it's a uniform rigid body, so the mass come down from the middle. Actually, if you look at the diagram, it's not so correct to assume this way, because if you see here, this part is thin, whereas this part is thick. Okay, so it's actually not very good to assume that it's a uniform rigid body. But never mind, our purpose is just to know how to draw free body diagram. Don't care too much about the details. Okay, so after drawing the mass, yes, this bar has mass, so it has weight. Second thing, is it connected to any string? Yes, you have a string here and you have a string here. So away from the object, along the string. So therefore, you have a tension somewhere here, and you have another tension which is somewhere here. Okay, so should I label them differently or should I label them the same? Let's just label them differently. Okay, so if this pulley right here, if it's a frictionless pulley, means by the pulley, its wheel is not rotating, it's just a frictionless vernier pulley. There's no wheel in there, it's just a frictionless pulley. So in that case, your T1 will be equals to T2. But we don't know whether it's frictionless or a normal pulley. If it's a normal pulley, then T1 is not equals to T2. Okay, if T1 is equal to T2, we can just write T. It's fine. Okay, so it depends on the situation. We don't know, so we just label T1 and T2. Okay. Next thing, any external force? No, I didn't see any force explicitly stated in this diagram. So next thing, oh wait, there's another tension. This is also a string as well. So you have a tension going down. Let's call this T3. Okay, so the next thing is friction. I don't think friction is relevant here. So the last thing, which is reaction force. Reaction force, look for contact surface or hinge. Okay, on this body here, let me wipe this thing off first. On this body here, we see there's a few contact surface. One is this thing contacting. Wait, that's all. Okay, that's the only thing contacting. So in that case, it's just a normal force pointing downwards. Sorry, it's just a normal force pointing downwards. Okay, normal force pointing downwards, because if this is your bar, the box there, it's pressing on the bar. Pressing on the bar means by it's pushing it downwards. Okay, so this normal is normal due to the box. Okay, so I believe that's it for the free body diagram. If you label the length, the way they draw everything is a bit weird. The only thing I'm sure about is if this is where the pulley is, so then the only thing I know is 7.7 meter. Then this whole thing is 3.4 meter. So the weight, the distance of the weight and this thing should probably B is 7.7 plus 3.4 divided by 2 meter. Okay, then this angle here I don't know, so I don't know the distance here, and I also cannot determine the distance here. I cannot determine the distance of this. I cannot, yeah, that's all that I can do. Okay, so that's it for the free body diagram, but I believe many of you might have different free body diagram from me because you label this as the weight of the box. Okay, you label this as your weight of the iron box. I'm not sure what is it. Okay, so if you label it as weight of the box, yes, it's correct. If you label it as weight of the iron box, is correct. Okay, you can only label either this or this. You cannot label both of them. You can label only one of this. Okay, why? Is because normal force of the box is actually just equals to the weight of the box. How do you know it? You know it from the free body diagram of the box. The free body diagram, it has weight of the box pointing downwards. For the free body diagram of the box, then you have the normal force exerted by the bar on the box. And since the thing is not moving, this thing up here should be equal this thing down here. That's why this end of the box is equal to this thing. So it makes more sense for us to straightaway label this, because weight of the box more understandable. This thing also same idea. You don't need to write T3, you can straightaway write weight of the iron box. That's fine. Okay, if you're not sure what am I saying right now, right, you may ask me personally. I'll try to explain it better. Okay, so that's free body diagram number 4. It's a bit difficult to discuss your responses. First thing is, I think this weight and normal, as I said just now, you can only have one of them. This normal should be wrong because the box is pushing down on the bar. The bar is pushing upwards on the box, but that's the force feel by the box. That's not the box. That's not the force feel by the bar. If you are drawing the free body diagram for the bar, we only want the force exerted on the bar. We don't care about the force exerted on the box. This one is on the box, so it's irrelevant for our case. Okay, there's only weight, but I believe this weight is not at the bottom, it's not at the end, so your line should probably extend more. Okay, your line of the object should extend more, extend out here. Okay, so this one is okay. The tension, I don't think is at the same position, it's slightly away. Don't need to connect to the pulley. Okay, this one correct, by label, should label it as T2 or whatever. This one, yes, this is the problem. A lot of you label the tension and label the weight, both of them. You cannot label both of them. This is the weight of the iron box. This is the tension exerted on the bar by the box. So technically you should label this, don't need to label this. Okay. Yeah. Don't need to label this. Okay, but at the same time, you know that this tension, what's happening? This tension on bar by the box is actually equal to the weight of the iron box, because if you draw the free body diagram of the iron box, there will be weight of the iron box cancel out by the tension on the bar, tension exerted on the box by the bar. Okay, then you know from Third law that tension on the box by the bar is having the same magnitude as the tension on the bar by the box. And because you know that tension on the box by the bar, you know that this thing is having the same magnitude as weight of the iron box. Therefore, weight of the iron box is equals to the tension exerted on the bar by the box. So this thing is here, so we can remove this and change it to weight of the iron box. It's a bit complicated to explain the whole thing, but what I can tell you is the bar only feel a force because of the string, but the tension exerted by the string on the bar is having the same magnitude as the weight of the iron box. So you can replace the tension with the weight of the iron box. That's the idea behind it. Okay, if you still cannot understand, come and find me and talk about it. I know it's a bit messy right here. Okay. Oh, this one you forget about the weight of the object. Weight of the bar. Okay. So there's a lot of version. Weight of the bar. So probably label tension 1, tension 2. This one you remove one thing. You can only have weight going down. Okay, this is weight of the iron box. Then this one is the weight of the bar. Then this one is the weight of the box. So this normal is not exerted on the bar. It's exerted on the box. So free body diagram only draw forces exerted on the bar. So the normal is not included in this free body diagram. Okay, the tension should be somewhere inside here. Okay, it's not at the end, then this object should be longer. This one, I include this picture just to tell you that you don't need to draw so nice. Okay, you represent the object with a single line. That's it. Then the rest just like up there. Okay, so that's it for FBD number 4. Sorry that it's a bit messy. Thank you.